As you are quite aware, there are dozens of videos on YouTube about rotary encoders. So why should I bother to make another Wait, the difference is this video is not about the theory of operations, and I won't be showing the gory details of the firmware or any schematic. But instead, in the rest of this video, I will demonstrate exactly how you can interface an Arduino sketch with this encoder library, which I use in my own projects. I think it is general purpose enough to be useful for others. Hopefully you will find it simple to use, plus it has some extra features that you won't often come across in other libraries. If that is what you are searching for, then keep watching. Let's get right into it. We'll explain what you can do with the Arduino Encoder C++ class with this step-by-step example. First, the library is designed to accommodate any number of encoders, limited only by the input pins available on your microcontroller. Therefore, we need to specify how many encoders we have in the project. In our example, 4 of them. Then we'll define the input pins we have chosen to connect with each encoder one by one. By the way, C encoder G4 is the name of the library class. The pins have to be listed in these orders. Now I won't show any schematic or circuit here because that depends on your own project and components. Next, there's one thing we need in the setup function. We'll have to make this one call, just like this, to establish the interrupt. Now we are ready. Let's say we want to check to see if there's any rotary activity in our loop function. We'll make a call like this whenever we want to find out whether we have any activity. The getQ function here returns 3 values. First, if there is an encoder action, getQ will return true, in which case this encoder will tell you which encoder is active, and action will tell you what kind of event has just occurred. So naturally, we need to define these 2 variables up here. Starting with the most basic activity, turning the knob clockwise or counterclockwise. We'll use a switch statement to process the various encoder actions. And we handle the cases for the clockwise and the counterclockwise movements first. By the way, all action codes are listed in the How to Use PDF. Don't worry, we'll work through all of them in this example. Let's perform some actual work based on the rotary activities. We'll use a counter to keep track of the number of clicks generated from each of the 4 encoders and initialize them to 0 here. Then, if counterclockwise, we'll add 1 to the counter or subtract 1 if it is counterclockwise. And finally, a call to a simple function just to display the result with the serial monitor. Here is the output from the demo. Responding to our clockwise and counterclockwise turns as expected. The number on the left indicates the encoder number 1 through 4. Next feature, the push button. We handle that with another case in our switch statement, like this. When the push button is pressed, we want to 0 the counter for the given encoder. Here is the response. Bonus feature, the long press. The class can also distinguish between a short versus a long press of the push button. If you hold the button down for longer than 600 milliseconds, it will be considered as a long press. We have a different action code to handle that here. Let's say for a long press, we'll just say so long on the serial monitor. And here is the output. Press and hold for a second. By the way, if your application does not wish to distinguish between short and long button presses, you just need to handle both cases using the same code, like that. Or you can call a member function to disable it altogether. Feature number 4. All the inputs for the encoders are interrupt driven. That's to make sure the library firmware will catch all the activities. But in order to help your sketch to not miss any action, we have a FIFO to buffer the activities. That's why you are calling the getQ member function back in the beginning of the loop. Let's demonstrate by injecting some delay into your sketch. This simulates when your sketch is completely off taking care of some other business for a couple of seconds. As you can see from the monitor, your sketch is able to catch up with every little count. No rotary action is left behind. A little delay, of course, but late is much better than never. Those basic features we have just covered should satisfy most applications. But if that's not enough for you, next feature, the turbo boost.
What we do is if we need that extra push over the cliff, you know what we do?
Put it up to 11.
11, exactly. One louder.
When you twist the rotary rapid enough, the library can recognize that and will report with a different action code. This happened when you have managed to clock in over 10 clicks within a 1 second time period. Here we add a different response to the burst mode detection. For this case, we can add 10 to our counter for each rotary clicks received instead of 1, effectively giving the rotary an acceleration. In the output, you can see the count jump from this point on to increments of 10. This can be handy when you need to dial through many turns to reach some numbers you want. For example, when you need to dial in a number for a compass heading between 1 and 360 degrees, yes, we need that extra push over the cliff.
But there is one more thing.
Alright, I need to come up with one last feature then. I can't think of a good name for it. I'll call it push and turn. When you turn the knob while holding the push button down, you'll get a distinct action code in return. Again, we'll make it respond with something different. How about counting in increment of 100? And it works. Push and turn makes the value go up and down in steps of 100. So you might ask, what good does it do? Perhaps we can use it to emulate a dual concentric rotary encoder. Just turning the knob, you get the normal output. Holding the button down and turn gets you a second set of clockwise and counterclockwise output. 2 for the price of 1, a poor man's version of a dual rotary encoder. Okay, that's all I have. You will find the link to the files in the description below, and I hope the example was able to explain the operations for you. Thank you for watching.